G'day chemistry students, in this video we are looking at dot point 8.1.3. Our focus is on precipitation titration, an analytical technique very similar to acid-base titration, but instead of doing a neutralization reaction, we're going to be looking at precipitation. Let's get into it. So when we're doing precipitation titration, there's still going to be a reaction between two different substances. There's going to be a standard solution that we know the concentration of, and an unknown that we don't know the concentration of. Alternately, we can be calling those substances the titrant and the analyte respectively. And just like an acid-base titration, we use the volumes used to sort of get to our endpoint or our equivalence point, as well as the concentration of the standard to be able to calculate the concentration of the analyte, the unknown. For most precipitation titrations, we're using silver as our source of ion that's pretty much always going to form a precipitation, meaning that we start generally with silver nitrate as our titrant, and the unknown or the analyte is, generally speaking, an ion which can precipitate with silver, which is pretty much most of them. Some precipitation titration methods are direct, meaning that you undergo a precipitation reaction, and then once that precipitation reaction stops, there's some sort of indicator present which will signal that endpoint. And the two methods that we're going to be looking at a little bit in this video are the Moore method and the Fian method. There's one other method that we're going to look at really quickly as well, and that's actually a back titration method. So it's a little bit more complicated. So in that situation, what we would do is react an excess amount of silver with the unknown, and then titrate the remaining silver that's in the solution to figure out how much of the silver from the original solution was consumed. And that's called a Vollard method. In particular, in class, we're actually going to be undertaking a Moore method. The syllabus isn't explicit about what types of methods you need to know and understand for precipitation titration. Generally speaking, back titrations like in the Vollard method are not exempt from being a part of HSC examinations. So it's completely reasonable that you should have somewhat of an understanding of how a back titration process works as well. This table just gives a little bit of a summary of how each of the three methods are similar and different at the same time. I'm about to deconstruct Moore method in considerably more detail than any of the others. Feel free to have a peruse. We can discuss some of the other methods and calculations in class. So for Moore's method, we have an unknown, our analyte, which is generally a halide solution, and that's going to be combined with chromate ions, which acts as an indicator. We then add silver, and that forms a precipitate. The silver halide will precipitate as a white cream color, and the silver chromate, when it finally precipitates, will be orange. In the GIF below, something that we should notice is that we start with our halide solution with a chromate indicator. So the halide solution would generally be clear, but the chromate indicator starts as yellow. As we add silver from the top, you can see that some of the silver chromate forms at the beginning. It's quite orange. We can see it there. But as we start to mix further, we can see that that silver chromate actually goes away and we start forming a white precipitate. The silver halide precipitate is actually going to form first. And all of that silver halide precipitate will form before the silver chromate starts to form. It forms afterwards, which is why it makes for quite a good indicator. And that's what's being sort of identified in this dot point here. Silver halide precipitates will form first, and that's that white color, before silver chromate precipitates and stays there as a precipitate. And the reason that is that halides are more reactive with silver than chromates are with silver. Looking at our titration here in the GIF, we're hitting that endpoint. What we see is that we end up getting more of that permanent orange color starting to come through. Once it no longer disappears, what that means is there is no more silver halide to be formed. All of the halide in solution has been consumed, and all of the silver that's now being added is forming silver chromate, meaning that we have hit our endpoint. Once we know that, we can take the volume of the silver that was added and use that volume, its concentration, and the original volume of the halide solution to figure out the concentration of halide ions. But there is a problem with Moore's method and the method that I just showed you, and that is that once we've actually consumed all of the halide and we've completed that precipitation reaction, we actually need to add additional silver ions or additional volume of the titrant to actually produce that silver chromate precipitate. And that's a problem because that's going to mean that the volume of titrant that has been added that we end up measuring at the end is going to be inaccurate. We've added more titrant than we actually needed. So what we can do is sort of do a little bit of a calibration or a zeroing step. In a separate process, we can add silver nitrate to a mixture of chromate and solid calcium carbonate in a solution. So if you mix around chromate solution with calcium carbonate, because the calcium carbonate's insoluble and is a white powder, it looks really similar to the halide precipitate. So you can mix that round and just add a little bit of silver nitrate until you get that positive indicator coming through, so that orange color that we just saw in the previous GIF. And by sort of setting that up beforehand, we can figure out how much silver nitrate was actually needed to be added to the chromate, and we could subtract that volume from our titrant measurements to make it as accurate as possible. Like most of our experiments and processes in this module, it can be a little bit difficult to sort of conceptualize at the beginning as it's being explained to you, and usually makes way more sense when actually doing the experiment. So we'll get in, we'll do it, we'll do the calculations. Just make sure you're coming into class with lots of questions, ready to learn this process and apply some of your chemical ideas that you've been learning about all year. Thank you very much, everyone. In the next video, we're going to be changing gears a little bit. We've been focusing on doing all sorts of inorganic tests to identify inorganic substances and measure their concentrations. We're actually going to be flipping again to organics. So we spent a lot of time at the beginning of this module looking at spectroscopy techniques and how to identify organic chemicals that way. The next video is going to be all about doing some chemical testing and chemical reactions to determine and identify functional groups present in unknown organic substances. But until then, have a good one.